So, hello everyone. Uh, Recently I ran into a problem. So this is the thing. You got the integration from 0 to pi upon 2 of dx upon square root of 1 minus a square sine square of x. So this thing you can try out this first of all, see if something happens. The way I thought that I could do this is write this thing as 1 minus a square sine square of x to the power of negative 1 upon 2. Taylor expand these things, basically, yeah, figure that out. And then we know how to integrate integrals of this form. So integration from 0 to pi upon 2 of sine power to kx and then dx, right? So we know how to do this thing. So using that, we can actually figure out what this integral is going to be. And yes, I did find out what this, right, the integral of this thing, what will that be? So the final answer that I got was 1 plus pi upon 2 times 1 upon 2 squared times a square plus pi upon 2 times 1 upon 2 times 3 upon 4 squared times a power 4 plus pi upon 2 times 1 upon 2 times 3 upon 4 times 5 upon 6 power 2 a power 4, sorry, a power 6, and then so on, right? But as you can see, this, yeah, I mean, this series is weird. We don't know what the closed form for this would be. So as a nice function, can you represent this? Well, actually you can't. Yeah, just can't. And people have tried already. There's a whole Wikipedia page for integrals of this form. I think it was called the elliptical integrals. And yeah, it's kind of like uh, you could calculate it using a calculator, right? Yeah, just put this thing in Desmos, put it as a function of a, and for different values of a, you will get different values of this integral, right? This is a function of a, by the way, because x is just a dummy variable, right? Um, or you could just use this series to calculate it manually. Both work. Yeah, both are answers for this thing. So yeah, but the problem is you don't have a nice form for this. This is as far as you can go. And also there are some other series that you can use to represent this, but once again, those are not nice forms. We want a form that is not a power series. So that's not an infinite series, right? So actually you don't have anything like that. And you can read the Wikipedia page called Quarter Period in mathematics, right? And there you will see that it's the same integral as what I'm doing right now. So how did I get to this integral? I was just figuring out what is the potential of a point in the planar region inside a ring which is of uniform charge density, linear charge density, right? What's the potential at this point? Um, yeah, and to do this, I actually had to do this integral, right? Yeah, basically it's just really hard. So you that's why you won't ever see a problem like this where you actually have to figure out the potential at some random point uh, on this plane. You won't have to do that because you cannot do that. That's the thing. So if you ever see integrals of this form or of any form that are elliptical integrals, just run away from that. You know it's not doable. So why spend your time in trying to solve them, right? So that's it. I'll see you guys in the next video.